Okay, so welcome everyone. This time we are going to talk about the structures, right? We are representing structures. Now we are not going to be writing carbon bonded to carbon, hydrogen, and all those things. No, we are going to represent structures. How are we going to do it? Now there's something I want to show you here. The simplest one that we all know is the showing of the lines. That is the line bond structures. For instance, if I write carbon, you know that carbon can form four bonds, right? Don't forget about this because that is the onset of organic chemistry. So let's say if I write carbon OH, I write hydrogen, hydrogen, hydrogen. This is the line bond structures. Line as seen, I'm using line to represent the bonds. So that's where the name is coming from, line bond structures. Calculate. It's also the same thing as the calculate structure. Do you get it? Now I can also write ammonia. You know how ammonia looks like. I can write in the condensed form NH3. Right? If I'm trying to write it in the calculate form, having my ammonia here, 1, 2, 3. So 1, 2, 3, and the lone pairs are here. Are you all following? So this is it. Now there's something I want to show you. As time goes on, we are going to have complex structures. We cannot be writing carbon bonded to carbon and all those things. It will take time. So now we are going to introduce you into new language, right? For if I want to expand this, I can even write it as the OH. I can just expand it and write O bonded to H. And now the remaining of it is the same thing as what you are seeing here, right? This is very important where I'm showing my electrons. So this is how come I'm having my line bond structures. Now, what we did is the representation of the structures, the dash formula, right? We're talking about alkanes. So see, I can have CH3. I'm writing carbon CH3, meaning this is the same thing as the CH3, right? It has been bonded to carbon. Now this carbon is also bonded to hydrogen, hydrogen, and now it's also bonded to carbon, hydrogen, hydrogen. It's also bonded to carbon, hydrogen, hydrogen, and now maybe probably hydrogen. You get it? How many carbons do you have? I'm having 1, 2, 3, 4 carbons, right? And the hydrogens too are also there. Instead of me taking my time writing it like this, now I'm moving to the dash formula. Dash formula in the sense that the dash formula starts from compounds that are having 2 carbons and above. You can't do dash formula for, let's say, only 1 carbon compound like methanol. No, you can't do it that way. The only thing you can do is that coming from 2 carbons. So you see, if I do a dash, if I do something like this, it is having 2.1, 2. It's having 2 ends, right? Let me use the word ends. Every end that I've circled here, see every end that I've circled here, it means that there's 1 carbon there. That carbon is invisible, but there's 1 carbon there. So I can write it as carbon bonded to carbon. And now if you don't see anything bonded to it again, then it means that everything is hydrogen. So now I'm having my hydrogen, hydrogen, hydrogen. You see? So what I'll take my time and write CH3 bonded to CH3. I can just write it as a dash. So this dash is the same thing as what you are seeing here. So every point represents 1 carbon. Now let's try and move to the next. I can also write something like, you see what you are seeing here? I can write it as 1, meaning there's a carbon here, there's another carbon here, 2, right? Then also another 1. So 1 carbon, 2 carbon, 3 carbon. I can also add another 1 again. So now it means that I'm having 1, 2, 3, 4 carbons in all. Then if you're not seeing anything there, if there is no bond to say that maybe it is bonded to chlorine, it is bonded to OH, it means that that bond that is invisible there is what? Hydrogen. Because carbon can form 4 bonds maximum. What I'm trying to say is I can also write something like this. So with this, I can transform it. I can just write it in the normal way. You write it as carbon bonded to carbon, bonded to a carbon, also bonded to carbon. It's the same thing as what you are seeing here. Just that this particular carbon can form 4 bonds. So 1, 2, 3. This side is already forming 2. so 1 2. This one is also already forming 2, so 1 2, and this one is forming 1, so 1 2 3. You see how it is? Then you can put hydrogens there throughout, because I'm saying that if I draw it and I just draw it like that, I don't indicate anything. It means that there are hydrogens around all the bonds that I'm showing. So this side is a hydrogen, 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 hydrogen. Do you get it? But if I draw something like this, so this is the dash formula. This is what we are going to use throughout most of our organic chemistry. If I draw something like this, and then I put OH here, right? If I'm trying to draw it again in this form, this means that I'm having my carbon bonded to carbon, bonded to carbon, bonded to carbon, bonded to carbon. So 1 2 3 4 5, as you can see. And now here it's forming one bond, so 1 2 3. This side is forming two bonds, so 1 2. This side, you see there is OH here, so OH. Then the other one will be hydrogen, right? Now this side will be also 2 bonds, and this side will be 3. Exactly. Now everything, just put everything there as what hydrogen. So hydrogen, 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 hydrogen. This is the dash formula. If you're able to understand this, it is very, very, very simple. Very, very, very simple. I can also draw something like, let's say, a carbon, but I'll not be drawing it way. Maybe I'll draw something like this. 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 I'll also do something like this, right? See, sorry. Now this is it. I can also put another bar here, or another, let's say, line here. It means that here there's one carbon 1 here. There's 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7. So it means that there are 7 carbons in all. If I'm trying to rewrite it like how you guys have been writing it always, then I'll write it as. So you see how, and I'm writing this way, it takes time. I can just do just some lines, and that will give me the compound that I want to tell you. So 1 2 3. I'm also having a carbon here. This is a carbon now. 4. So this is a 5th carbon. This is a 6th carbon. This is a 7th carbon. You see, instead of me taking time to do all these things and now represent the bond, hydrogen, 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 1 2. This carbon is forming 3, so it's left with only 1. Now here is forming 2. This side is forming 2. This side is forming 1, so 3 in all. Now hydrogen, 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 hydrogen. Now let's come to this. This is also carbon, right? This carbon can also form 3 bonds, so 1 2 3. There's also hydrogen, hydrogen, hydrogen. You get it? Then now a hydrogen, a hydrogen, 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 hydrogen. So instead of me doing all these things, drawing it and rewriting the structures, hydrogen, 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 I'll just do something like this. And it's the same as what you are seeing here. So now we are introducing a different language in all, where we are going to talk about compounds. By these compounds, we're going to see any lines. At any point, any vertex, there is a carbon there. And if there is no other thing attached to that carbon, it means that everything there is hydrogen. So I can rewrite it again. Let me try another structure for you. I can have a structure like, now even let's go to the part where it's having a double bond. That's also interesting. I want to also let you know some parts here. I can have a carbon. See, I can have a compound like this. Compound 1, let's say 1 1, and let's say I'll put some double bond here, and I'll put something like this. If I draw something like this, you see how it's very simple for me to draw. How many carbons? 1 2 3 4 5. Here there's a double bond here. If I want to redraw it like how you guys have been drawing it, I'll just write my C, bonded to C, bonded to C, and now here you see there's a double bond here, so 1 2. Now carbon here, carbon 4, and now carbon 5, right? And now I'll start putting the hydrogens there. 1 2 3. Here is also forming 2, so 1 2. But here look at this carbon, 1 2 3. So left with only 1 bond. This one's also 1 2 3. Left with only 1 bond. You get it? And now that gives it. This one is also a carbon, right? Because you're having 1, 2, 3, 4, 5. You're having 5 carbons, so this one's also a carbon. Now this carbon is bonded to only one, so 1, 2, 3. Now everything becomes hydrogen. So 1, 2, 3, hydrogen, 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 hydrogen. Now let me try another one also. If I'm doing something like 1, 2, 3, 4, and let's say here I'm putting a double bond here, double bond here. I'm also putting a double bond here, double bond. If I do something like this, see how it's very simple for me to do, just some lines, right? If I want to redraw it, I write my carbon, carbon, and here there's a double bond, so 1, 2, carbon. Here there's a carbon, here there's 1, 2, then there's also carbon. You see, that's all, because here there's a carbon there. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, as you can see. Then this carbon is already forming 1, so let me 3, 2, 3. Now this one's already forming 3, so left is only 1. This one's also forming 3, so 1. This is also forming 3, so 1, right? And this one is forming 2, so 1, 2. Everything becomes hydrogen. 1, 2. Everything that you see, all the dots that I'm doing, or the round things that I'm writing, they are all hydrogens. So you can see how me doing all these things, if you look at my hand, right, writing all these things, your hand will even pain you. How to just be using these lines? This is the most simple ones. So this is very simple, right? So this is the dash formula. So from there, we are not going to start writing compounds and writing carbon unless maybe it demands us to show the bond between the carbon and some atom, right? If not, we are not going to do it that way. So with this, I can even write a compound like this. I can write a compound like here. I can do something like this, 1, 2, then I'll just do something like this, oxygen, you see, then I'll just move on, something like this. What you are seeing here is very simple. What did I tell you at first? Carbons, right? So every vertex is a carbon, 1, 2, 3, 4. You're having 4 carbons in all. Then I can write it as carbon bonded to carbon bonded to a carbon, but here you are having a double bond. This represents a double bond to oxygen, and here you are also having a carbon. So from there, 1, 2, 3, 1, 2, here 1, 2, 3, as you can see, because carbon can form 4 bonds. See, it is already forming 4 bonds, so there's nothing to put there again. 1, 2, 3, 1, 2, 1, 2, 3. Very simple. So this is how come we do our dash formula. So the next thing we are going to look at is how to identify structures in 3D.